Good morning and welcome to our live stream. We'll get started here in just a few more minutes. We apologize for the delay. We'll get started here in just a few more minutes. Thanks so much. Welcome everyone to the live stream. We're going to get started here in just about another minute. Thanks so much. All righty. Good morning, everyone. My name is Will Tapia. I am with Big Brothers Big Sisters of Central New Mexico as an advancement coordinator here. Welcome, welcome, welcome. We're so happy that you are all here. I'm seeing a lot of the chat box being used already at YouTube. We apologize for the delay. We're having some technical difficulties on our end, but it should all be figured out. So welcome to our second week of our virtual Discovery Festival for 2020. I'm going to just briefly mention what this looks like outside of a pandemic. So normally Discovery Festival is a one-day event held at the Albuquerque Convention Center where we get about 3,000 students all from around central New Mexico who get to participate in hands-on STEAM exhibitions from 50 plus exhibitors. STEAM, of course, is science, technology, engineering, art, and mathematics. So it's this hands-on, totally in-person, awesome, dynamic event. However, this year, 2020, as we all know, puts us in a tough situation with in-person events. Because of the COVID-19 pandemic, we've had to pivot our entire Discovery Festival event into this virtual space. So this is a new thing for us. This is a new thing for all of you, I'm sure, too, as some of you navigate hybrid learning models, totally virtual learning models, and things like that right now. So we're there with you, and we're here to bring you awesome, fun, and exciting STEAM exhibits. So some kind of ground rules very quickly as we get started. If anything happens to this stream, if we have technical difficulties going through the stream, which I don't think we will, but just in case. If we do, go right back to the BBBS CNM YouTube page, the one that you're on right now, Big Brothers Big Sisters of Central New Mexico, BBBS CNM. Go right back to the YouTube channel and we'll have the stream back up shortly. So if anything crazy happens, just do that and we'll be up and running pretty quickly there. Another fun thing, and I see everybody's using it right now, which is awesome, is the YouTube chat feature. So we have a chat going there on your screen. So if you have a question, if you have a comment, type it there and I will ask our exhibitor live on air. So if you tell us even, hey, my name is Will and I'm watching from here, let us know. I'll read them out on the program. Keep it dynamic. Keep it fun. We want you all to get something out of this program as well. Also here, as we get started, I wanted to just do one real quick thing. I have 10 windows open right now that I'm trying to navigate through, but I wanted to give a quick shout out to some of our amazing sponsors for this event. What you're seeing, all this kind of stuff would not be possible without these amazing sponsors who are supporting us. So shout out to Honeywell, who is our Da Vinci presenting sponsor. Honeywell is awesome. They're doing a presentation this Friday. We're adding it to the schedule today. So teachers and students, if you're watching, be sure to check that out. We're going to send out emails today from our staff that'll have the live stream link and all that good stuff. And of course, it'll go live on our website by the end of today as well. So stay tuned for that. Honeywell this Friday. Thank you so much, Honeywell. And we're also scheduling them, I think, for next week as well. So stay tuned for all that stuff. It should be a blast. To our Curie sponsor, Fidelity Investments. They're going to be on this afternoon at 1 p.m. They're going to be talking about what is credit. That is such an important thing. We hear adults talk about it all the time. I didn't even know what credit was until very recently. So what is credit by Fidelity Investments? I think you guys are going to absolutely get a huge kick out of that. Be sure to roll on through our live streams and check that out as well. To our ride sponsors, to Aztec Machine and Repair out in beautiful Bloomfield, New Mexico. Thank you so much, Aztec, and to Air Force Research Laboratories. They're coming on next Tuesday, the 17th, to talk about satellites. And so some teachers have an awesome special surprise from AFRL. It should be super, super great. We are so excited to welcome Air Force Research Laboratories onto the stream. And to our Newton sponsors, Defense Threat Reduction Agency, who's coming on also next week, to Micronet Solutions, Sandia National Laboratories, and to Presbyterian Hospitals. Thank you all so much for your Newton sponsorship. And just a big shout out to all of our sponsors once again. Thanks, everyone. All righty. I think that's everything that I have to cover. I have all these different lists of things to go through, but please, again, don't forget to please use that YouTube chat. That's how we're going to be able to read your questions live on air. Whew. Okay, without further ado, I'm going to introduce our guests for this morning. We have a special guest from Virgin Galactic and the Spaceship Company, Chris Huey Spence. Chris, how are you?
Good morning, Will. I'm great. Thank you. How are you?
Doing really well. Good morning and welcome to the live stream. Chris, I think everybody is super sick of hearing me talk. I'm very long-winded. I tend to have that problem. So I'm just going to fully kick it to you. And like I said, if any questions come up, I'm just going to jump in if that's all right.
Yeah, that's absolutely great. I appreciate that.
Perfect. All righty.
Well, good morning, everybody, from wherever you may be, at your home or in your school. I'm calling you today from my home. As you know, the COVID pandemic has changed things a lot for all of us. So I am working from home, just as I'm sure many of you are going to school from interesting places. So I'm here to talk to you a little bit this morning about what we do at Virgin Galactic and the Spaceship Company. So I'm going to share my screen here. Bear with me as we figure out technology together. And hopefully all goes as planned. Okay. Oh dear. I got a lot of screens going on here, so just give me a few seconds to find which one I need to share. All right, it tells me screen 3 is the right one. All right, so yeah, let's get started here. So like I said, I'm here to talk to you a little about what we do at Virgin Galactic and the Spaceship Company. We are sister companies, so I'm sure you guys are familiar with Virgin Galactic as it's our outward-facing brand, but we do a lot of interesting work on both sides of that. So moving along here, little overview. We don't really need to get into the details. We're going to go dive into each one of these topics: introduction, who am I, what do I do, what is Virgin Galactic, Spaceship Company, and a bunch of fun, exciting things. So if you haven't heard what we do, I'm going to play a little video for you, and hopefully that can be exciting for all of us. So without further ado, here's a little summary.
Fire. Fire. Hey, welcome to Space Scotland. Congrats, Dave.
Welcome to the club, astronaut.
Thanks, Space. I like this club.
Okay, so there's a little fun video to watch so you can see exactly what it is what we do. I think the video kind of explains it all, but we are in the business of sending people to space. So hopefully you're excited about what we're about to show, but first, I guess I should introduce myself a little bit. So like I said, my name is Chris Huey Spence, but everyone calls me Chewy. So I'm originally from Orlando, where I was raised there, and then spent most of my life there until I went to college. So I have a degree in aerospace engineering from the University of Maryland, up there on the right-hand side. Ever since I was young, I always wanted to study helicopters and build and design them. I don't know, I just really got excited about helicopters. So I ended up at University of Maryland. I spent some time interning at a company called Sikorsky Aircraft. They're up in Connecticut, up the top right. So I spent a couple summers there interning and doing engineering things like mechanical diagnostics and aerodynamics. And after college, I graduated and I got a job at Bell Helicopter, now known as Bell Flight, in Fort Worth, Texas. I was there for about 5 years. I held 2 different positions. One as an external loads engineer, and we'll get into what that is a little bit later. And another one as a simulation engineer, where I basically got the chance to build and develop flight simulators. That was really cool. Probably one of the coolest things I've done before I came to the Spaceship Company. So yeah, I spent about 5 years there. And then after that, I got recruited to come out to California, where I am right now, Southern California, working for the Spaceship Company. So right now I hold a role called group lead. I lead several teams, group lead of technical disciplines in loads, dynamics, flutter, and thermal in our flight sciences organization, which is kind of what it sounds like. It's our job to investigate the science of flight and then ensure that the vehicles do what they are designed to do and all that good stuff. So moving on, here's a fun slide I put together. I like this one a lot because it kind of showcases all the different vehicles I've gotten to work on in my career so far. So like I said, I was kind of a helicopter nut. And so that's obviously why I went to work for Bell Helicopter and even got some time at Sikorsky. So this one here was the V280 tilt rotor thing. Maybe you've seen it in some movies like the V22 and Transformers. This was a simulator I worked on. I actually got to go to Europe, Spain for a couple of weeks to go certify this simulator with the European Safety Agency and some other helicopter projects I worked on. And then kind of what I'm going to tell you about today is the spaceship and White Knight 2, our mothership. So before
I do have a question, if I could jump in here. So Brian wants to know if you get to go to space.
If I'm going to get to go to space, I hope so. One of the things that why we exist is to open up space to as many people as possible. And I hope I personally get to go. I have to do a lot of politicking in order to make that work. But let's say we will be sending humans to space in the near future as we get ready to go into commercial service. So I'm not sure if I'll personally get to go, hopefully one day. But yeah, thanks for asking.
Awesome. Yeah, and we have a couple shout outs here real quick. So from CC HS, I'm not sure what that acronym is, but CC High School in Albuquerque. Thanks so much for being here. Looks like we have Central New Mexico Community College Aviation Maintenance Program is on the stream as well. We have Tres Volcanes in Albuquerque. And yeah, some other schools are coming in as well. So welcome everybody to the stream. Thanks for being here. Don't forget to ask your questions. And I'll ask Chewy, that's okay.
Yeah.
I could ask Chewy here on the stream. So drop your questions in the chat. Thanks.
Yeah, great to have everyone on board. Sounds like an exciting bunch of folks out there. So thanks for joining and being a part of our presentation this morning. So what is our mission at so at Virgin Galactic? Our mission is to be the space line for Earth, which means we focus on using space for the good while delivering an unparalleled customer experience. Through our work, we believe we can help inspire future generations and make it possible to see our beautiful home planet from a new perspective. So that was a well-timed question, Will, thank you. Will I get to go to space? I certainly hope so, but our mission is to get as many people in space as possible, because we really do believe that getting the perspective of seeing our tiny blue dot from up in space will provide a new perspective to all of us and give us something to hope for and work towards together as a species of humans. Oh, but what's that? Our missions. Well, we actually have several missions, and our second one is making dreams take flight. And so the reason I've kind of isolated these two different missions is, is because we actually have two different companies here. So like I said, we're two companies in one, but we have the same DNA. So I work for the Spaceship Company out in California, and our sister company is Virgin Galactic, located in New Mexico right now. And the way I like to think of it is it's like peanut butter and jelly in the same jar. It's just better together and really, really convenient. So I'm going to tell you a little bit about how we're structured and kind of the difference between the Spaceship Company and Virgin Galactic. Here's a little quiz for anybody who wants to chime in later in the chat. But this here is what we call the DNA of flight. It starts at this little guy with wings and ends with that is obviously the spaceship that we're flying right now, Spaceship 2. If anyone can come try and figure out what the rest of these things are in our DNA of flight and how we got from here to there. So bear with me, this is a fun analogy, I think. So Virgin Galactic is what I like to think of, it's like you're going to a puppet show or to the theater. It's the outward facing brand that most people recognize. And it's the service organization that will go send a bunch of people to space. And so what is Virgin Galactic responsible for? Well, Virgin Galactic does the customer experience. If you've ever been a part of any Virgin brand, Virgin company, or have even flown Virgin Airlines or something like that, you know that customer experience is one of the most important aspects of running the business. And so the customer experience is unparalleled with Virgin Galactic, and I think this is going to be a really nice and exciting ride for those of our future astronauts that get the chance to ride on the spaceship. So Virgin Galactic is also responsible for flight operations, and all of the pilots, even our test pilots, work for Virgin Galactic, as they will be our pilots in commercial service once we start flying people. We'll also have the capability to fly research payloads. We have flown research payloads in the past, and we will be flying them in the future. So it's part of our NASA Flight Opportunities program. And I think the really cool thing about this is, the access to space is super expensive. And, in the past, when we were sending research payloads up on the space shuttle, you had to spend years and years and years to get your research project just right, so you could put it on the space shuttle in a couple of years, and maybe you get a couple of weeks to use it on the International Space Station. And then if it breaks, hopefully the astronauts can fix it in flight. But if it breaks in space, that's kind of it. Your science is over, your research is over. So making space accessible with Virgin Galactic and research kind of gives researchers a chance to get the results almost immediately Your payload will go to space in an afternoon and come back, and then you can get your results right away. And if it doesn't work, you can tweak things and send it back to space next week if you want. Our astronaut training is also what Virgin Galactic is responsible for in keeping our customers engaged and getting them ready for their future space flight, and also and bringing them into a community after their space flight. Okay, so now
get
yes.
a couple of questions. So, and we did have a guess as well about the crafts there on the right side of the screen. So,
Sure.
So let's see here. So one of the students is thinking that the first plane invented the third one. But I think if I'm not mistaken, right, Chewie, it starts at the bottom and then works its way up. So the bottom is like the primitive thing, and then it just works its way up. Okay, so take another guess. That was a great guess. Take another one, everyone. Let's see here.
This
so
is the first airplane. Give you that hint.
Ooh, okay, that's a good one. The first airplane. So Davidson would like to know if you work with NASA.
We do on both the Spaceship Company side and the Virgin Galactic side. So on the NASA side of things, we've actually signed several agreements in recent history to help train future commercial astronauts. And as I mentioned, we're part of the NASA Flight Opportunities Program, where NASA wants to give the general public opportunities to send payloads to space and do research.
Awesome.
On the Spaceship Company side, NASA has been a research organization for decades, and we stand on the shoulders of giants. So we try not to reinvent too many things if NASA can help us out. So we work with a lot of the NASA research centers to help develop the technology that we're working on.
And Brian wants to know how many people you all send to space.
Well, we're still in our test program right now. So we haven't sent any paying customers to space as of yet. In our last powered flight, just under 2 years ago, we sent our first test passenger, if you will, Beth Moses. She is actually our astronaut trainer, and so she'll be responsible for training all of our future customers on what to expect and what the flight experience is like, and then just fine-tuning the details to make sure it's the best possible experience for them. So to date, we've sent several of our pilots to space. The exact number escapes me. It's probably around 5, plus our Beth Moses, our test passenger.
Awesome. Yeah, and I think that dovetails into Davidson's second question to see if he could go to space one day.
Oh, you certainly can. Yeah, I think this is an exciting time to be around. It's kind of like the second space race. I've heard it called many times, and so our goal is to open up space for as many people as possible, to the point where it is just as common as just flying across the country on a commercial airliner. So just like flying American Airlines or Delta, we hope that in a couple of decades the cost will come down and it will just be like going to Disney World, but the ride of a lifetime.
Awesome. Okay. We got some more really good questions, but I'm going to save them for a little bit later, so I don't interrupt your presentation too much.
No worries.
But keep them coming. Keep them coming, students. Keep them coming. They're great.
So we're backstage now. We're backstage, and this is where the Spaceship Company kind of comes in. So what the Spaceship Company is responsible for is a lot of the design, build, and test aspects of all of the vehicles that we support Virgin Galactic with. So we do analysis. This is an example of what an analytical tool may present in terms of like aerodynamic distributions around the vehicle. We also build spaceships. So you see we're putting it together. Most spaceships are built out of, or most of the spaceships built out of carbon composite, which requires some curing. So here's this example of building an oven around one of the components to cure that. And we also get to test a lot of the components. We test every component, actually. And so behind the scenes, Virgin Galactic is the Spaceship Company, and we kind of develop the technology and test it out, and then prove it and make sure it meets our requirements and is exactly what we want for the customer, which is Virgin Galactic and then our future astronauts. So I kind of mentioned this before, but the Spaceship Company is responsible for the design, build, and test aspect of everything. And then we build, the spaceship, and then we also build and support the White Knight 2, which is our mothership. We'll go into that in a little bit. And we also do more. So behind the scenes, not just what we're doing with the spaceship platform and sending people to space, we're also developing new technologies and working with our partners there to kind of see what the future of travel is. And so that's that second part of the mission I was talking about, making dreams take flight. And so here I've just kind of shown an example of one of the new projects that we've recently announced, which is a high-speed transport. So that's kind of our, around Mach 3 commercial transport airplane that we're looking at. So Mach 3 is really fast. For those of you that don't know, Mach number is essentially the speed of sound. So when you say Mach 1, that means 1 times the speed of sound. When I say Mach 3, that means 3 times faster than the speed of sound. So this is like flying from, LA to Tokyo takes like 15 hours. Flying Mach 3 would probably cut it down to like a couple hours. So very, very high speeds we're talking about here. And so we're working on lots of those types of projects too. Okay, just a moment here. Okay, sorry about that. Great. So next we have, let's see, the space flight system. So this is our bread and butter. This is what we do. The space flight system is our way of sending people to space. And so this looks a little bit different than what you may expect a traditional rocket to look like, where it's vertically launched from the ground and kind of looks like a tube with a tiny little bit of people, and then everything else is fuel. Our spaceflight system is a 2-staged air-launched rocket plane. So we have a mothership kind of outlined in blue, and then you can think of it as the baby ship or the spaceship, which is kind of centered here in the middle. And then it's also got our hybrid rocket motor system, which powers the spaceship. So yeah, that kind of begs the question, why use an air-launched rocket? Why not just launch from the ground like everybody else? And so, one of our major goals as in our mission is to make this as widely possible, widely acceptable and very attainable in the future. So here's some of the advantages of using an air launch system. So scenario A on the left is, imagine you have to climb a lot of stairs. Here's a picture of a skyscraper. You start at the bottom and you need to climb to the top of this skyscraper, 102 floors. It's probably going to take you a very long time and a lot of energy. So that would be analogous to launching the spaceship from the ground, and you have to take a lot of fuel. You need a very big rocket in order to do that. And so now imagine scenario B, where if you get a piggyback ride, maybe someone could take you up to, say, the 40th floor, and then you only have to take the next 62 floors, walk yourself to get to the top. And so essentially what that allows us to do is to expend less energy and take less fuel with us. And when you're talking about space platforms and rockets, weight is everything. You want to keep your weight down as much as possible, because every pound you have is a pound you have to take to space with you. And it takes a lot of energy to go all the way up to space. And so what the air-launched rocket allows us to do is, by launching the rocket at a higher altitude, that's fuel that the spaceship doesn't have to carry, which means the spaceship can be smaller and more efficient to get to the same altitude and serve its mission. So in this example, it's like getting a piggyback ride, a third of the way up, and then you only have to take the stairs the rest of the way. You still have a long way to go, but you did save a lot of energy and you are able to take less fuel on the way up. So that's one of the basic advantages of using an air-launched rocket. There's a lot of operational reasons to do it too. Kind of fly above the weather a little bit as well. So here's White Knight 2. This is our first stage. So it is the largest operational carbon fiber airplane in the world right now. It's got a very unique twin fuselage design, pretty big wingspan, 141 feet. It flies very high relative to most airplanes. About 53,000 feet is its maximum altitude. Flown by 2 pilots, as is the spaceship actually. And it's really good at carrying heavy payloads very high. So there aren't really a whole lot of other airplanes in the world with these capabilities that can fly this high with with a huge payload. In this case, that payload is spaceship. So interesting fact is, White Knight 2 is a very big airplane, but when it's empty, when there's no fuel in White Knight, it actually weighs the same as the spaceship with full fuel. The spaceship is considerably smaller, but they're very similar in weight class. So how high is high? Well, this yellow dashed line here at the bottom is approximately how most commercial airliners fly. So when you're hopping on a plane in normal times to go visit family or friends or whatever it is, you fly about here at this yellow line. And White Knight 2 flies anywhere from 20 to 25,000 feet higher than that. And then just for perspective, our spaceship goes significantly higher than that, way up here above 250,000 feet where we consider the line for space to be. So White Knight 2 flies pretty high by itself, and you actually get a pretty good view of the Earth. You start to see the curvature of the Earth even from White Knight 2 altitude. But the views only get better from there as you hop on the spaceship and go up a couple 100,000 feet. So here's some basic design features of the spaceship. It is the second stage of our space flight system. It is an all composite aircraft similar to the White Knight 2. It uses a hybrid rocket motor, which we'll get into a little bit later. Flies really fast, faster than Mach 3, but pointed straight up, right, as we're trying to go to space. It's flown by 2 pilots, not by computers. There's actually 2 humans in the front of the ship in control of everything. And it is designed to take 6 spaceflight participants, which is what we call our customers or our future passengers. Take 6 people to space in addition to the pilot, so seats 8. And some of the craziest design features, we'll get into some of those, actually folds in half. So we'll have to figure out like, hey, why would you fold an airplane in half? That doesn't make any sense. It also acts as a glider and lands as an airplane. And I mentioned before in kind of our skyscraper example is you want to save weight as much as possible. So there's a lot of weight saving features in the design of the spaceship that we'll breeze through in a minute here.
Awesome. Well, you mentioned faster than Mach 3 for this, and we did get a question about the speed of these aircraft. If you could explain that just briefly here.
Yeah. So at sea level, the speed of sound is just over 700 miles an hour. So imagine going 700 miles an hour. Well, it's kind of hard. Most airplanes that you fly about 500 miles an hour, so to speak, maybe 550 at very high altitudes. So the spaceship is flying considerably faster than that. And the speed of sound is a lot of interesting things happen when you fly around the speed of sound. So not many airplanes fly close to it. You want to fly either just below it or way above it. And so we fly 3 times the speed of sound with the spaceship, which means we're flying, at upwards of 2,500 miles an hour. So we're covering a lot of distance, but we're going straight up. So the speed of sound is an important thing for engineers to consider because the way the air flows around the vehicle changes a lot depending on how fast you're flying. So we pay attention to things like the Mach number so we can make sure we have good control and that the vehicle performs as we expect at all the different speeds that it needs to fly.
It's amazing. It really is amazing. And then, I guess off of that speed as well. So one student wants to know, like going to space, how do these astronauts have to prepare for it and just kind of the toll it takes on the body?
That's a great question. I'm going to get into that one a little later, if that's okay. We're actually going to go
yeah.
in detail of kind of what that looks like and how the astronauts would prepare.
Awesome. Yeah, that sounds great. And another question is asking about how the ship holds up coming back down into the atmosphere.
I'm going to get into that in a couple of slides. That's a
Perfect.
Great question.
I love it. These are great questions, students, because we're preemptively jumping into it. So, okay. So let's see. This one asks, so when you're going up to space, how long for these trips would the guests stay in space? And they just stay inside of the ship, correct?
They do. They stay inside the ship. We're doing what's called a suborbital space flight, which basically means it's a little, we're not orbiting the Earth. We're not going around the planet as suborbital. So we go up and then we come back down. And so your total time in space is about 4 to 5 minutes. But as we'll see as we go through the mission profile, You take off from a normal runway like an airplane would. It takes about an hour to climb up to the release altitude with the mothership and the spaceship attached. And then you release the spaceship, burns for about 60 minutes or 60 seconds, the rocket motor. And then after that, you unbuckle and you're weightless. And that's when your space journey begins, and you spend a couple minutes in space. You get to float around the cabin. And then it takes about another 15 to 20 minutes to land back at the same runway you took off at. So you're talking about, an early fun morning. It's not a whole day trip, but you get to spend several minutes in space. I think the best analogy of a suborbital trajectory is imagine you have a baseball in your hand and you just throw it up. It goes up, it reaches some high peak, and then it comes back down. That's basically what we're doing, only it takes a rocket and we're throwing up that baseball very, very high, over 50 miles. So
That's pretty great. So you could have breakfast here on Earth, go up into space, and then be back in time for lunch, basically.
yeah, exactly.
Wow, that's phenomenal. Two more quick questions. So how many spaceships have you made here in New Mexico?
Good question. So the spaceships don't actually get built in New Mexico. That's where that difference between Virgin Galactic and the Spaceship Company come in. So the spaceships get designed and built in Mojave, California, where the Spaceship Company is headquartered. And then in New Mexico is where the operations will be. So there aren't any spaceships built in New Mexico, but they will be housed there. And there's one spaceship there now and one mothership. We are working on building some more, which I'll get into in a bit. But right now we have one spaceship and one mothership, Eve, White Knight 2, that's currently in New Mexico.
Awesome. Okay, and one more question, and then we can move forward. So is that faster than Mach 3? Is that the fastest spaceship that you all have built?
Yes, it is the fastest spaceship that we have built so far. So I'd answer yes to that. I'd say speed isn't quite as important at those high altitudes as you're pointing straight up and the atmosphere starts to thin. But yeah, it's a pretty fast spaceship. It's a wild ride, and we'll get into like what that experience is like. But yeah, it's a pretty gnarly ride.
Perfect. Thanks.
Thank you. Great questions. Please keep them coming. So this is a very busy infographic. We're not going to get into all the details here, but this starts to isolate some of the major design features of the spaceship. As I mentioned, this is kind of the rocket motor system. Here's me alluding to the fact that the vehicle folds in half. So these two big things on the side, we call those the booms. They're akin to the vertical fins on a normal airplane. They fold in half and reconfigure the vehicle for reentry. We also have some elevons. We've got some actuators. We have reaction control systems, which is our thrusters. So how do you control the vehicle in space when there's no air? We actually shoot air outside of the tips of the wings and the nose to change the attitude or the orientation of the vehicle as it's in space. We call this whole big system back here the feather. That will become apparent in a moment. And as I think some of you are probably wondering, like, how do we enter the atmosphere safely? Because it doesn't get really, really hot? The answer is yes. And here on the leading edges of the wing, you see this darker color. We call that the thermal protection system, or TPS. So the spaceship being an all carbon composite vehicle means we have to protect it from high temperatures. And so we kind of put a layer of this special coating on it to protect sensitive areas from getting too hot, both in the boost profile when the rocket motor is on, and then on reentry when we come back down through the atmosphere. So why does Spaceship 2 fold in half? That is something that I've never seen any other airplane do. So the Spaceship 2 feather system combines the natural stability of a shuttlecock, which is kind of the game ball in badminton, if you ever played badminton. Natural stability of a shuttlecock and the optimized aerodynamic deceleration of a capsule. So I like to think of Spaceship in what we call the feathered configuration as a combination of a space capsule and a feather and a badminton shuttlecock. And so these are a couple of the design features that allows the spaceship to save some weight. As if you may recall on the space shuttle, they had all those black tiles on the underside. That was to protect the belly from re-entry heating. And so we do have to do some thermal protection, as I mentioned before, but by putting the vehicle in this configuration, it actually makes it very stable. So even if you come in upside down, the vehicle has a natural orientation where it will want to right itself bottom down and top up. And so we get some of that stability from both that capsule design and the feather design. So we combine the low center of gravity from both the capsule and the shuttlecock, and then those kind of high aerodynamic flight surfaces, which gives us a nice stable re-entry. So we make sure we're pointing in the right direction when we come back down. And then by pointing the belly down towards the earth and coming back that way, it gets a large surface area. So it's actually like having a big parachute as we come back down. And so this helps slow down the vehicle substantially. And the slower we fly, the less hot the vehicle will get. And so because of this system, we actually get to save weight by not having to put quite as much thermal protection system on the ship, because we're able to slow it down just using basic physics, principles of physics. And so that's kind of that blunt edge that we see here on the capsule. We try to mimic that feature on the spaceship by deploying the feather up and coming back down belly first. So essentially, we're just belly flopping back into the atmosphere when we come back from space. And this by far is probably the most interesting and novel feature of the spaceship, I think. But there are some other ones. So if you look closely at that picture, you might notice something a little strange here. There's no nose wheel. What's the deal with that? Well, this is another one of those clever design features where we actually try and make things as simple as possible. And simple usually means easier, less complex, less expensive to operate. And in this case, it actually saves weight, and it does exactly what we need to. So instead of a nose wheel, we actually put, this is a laminated piece of wood. Sounds pretty low tech, but I personally love low tech solutions to complex problems. I think that's a really clever way to do it. And so it saves weight. We don't have to carry a big wheel in here. And then this also serves as helps the brakes, helps us slow down when we land on the runway. So by having a nose skid, that creates some friction on the runway, helps slow the vehicle down as we skid to a halt, and also helps us to have actually smaller brakes than we would otherwise need to slow the vehicle down on that runway, since we're slowing down due to friction on the spaceship nose skid. So this is another weight-saving feature that helps us go higher and helps us have a better customer experience by spending more time in space by saving weight. So how do we get to space? Well, this is the business end of the spaceship, if you will. So this is our rocket motor. It's a hybrid rocket motor, which kind of combines two major features of traditional rockets. So this rocket puts out about 65,000 pounds of thrust. We burn this rocket motor for about 60 seconds. And it's got very few moving parts, which I think this is another one of those simple to design. Relatively, it's still very complex in terms of a rocket, but and it's got some, fueled by nitrous and helium as our pressure tank to help kind of shoot all that rocket fuel through the nozzle. And what we're looking at here is called the CTN. It's a special rubber compound that is our solid rocket component. It stands for the case throat nozzle. You can see this is the case where the solid rocket fuel is contained, and then the throat, and then fire shoots out here through the nozzle. And so one of the major benefits of this hybrid rocket design is it includes the high thrust capability of a solid rocket motor with the safety of a liquid rocket. So liquid, if you just turn a valve and stop shooting the fuel, the rocket will turn off. With a solid rocket, usually once you burn it, that's it, it goes. It's kind of like a sparkler on 4th of July. And so here I have a graphic of the space shuttle, and it used both solid and liquid fuel. Not quite in the hybrid sense that we're talking about here, but it's a good example. Once you light one of these solid rocket boosters, you cannot turn it off. You are just along for the ride, and you have to have other means of distancing yourself if you need to shut down the rocket for any reason. So we kind of have the best of both worlds, where we have a solid for the high thrust, and we have the liquid for the safety and great for testing. So we have the ability to do shorter duration burns if we want to just test out certain features of the spaceship, as we're doing now currently in flight testing. And so in the event that we need to shut down, we shut down the rocket motor. Instead of going to space, we shut it down and we just glide back like a normal airplane. And we've got all of our bases covered. So someone asked, how many spaceships are we flying? We're flying one right now, but we are building a fleet of vehicles. So this is a picture of another spaceship that is currently in design and being manufactured here in California. So we have more people signed up to go to space with Virgin Galactic than have ever been to space before. That number is over 5, maybe close to 600. And so we can't fly thousands of people, we hope, on just one spaceship. We have to build a fleet of them. So we are doing that. Here's an example of one of them. Here you can clearly see, without the fancy paint job, you see the carbon fiber composite underneath. And we're starting to assemble that. Excuse me, my cat likes to, sit in front of the computer because she's selfish like that. It's always about you, cat. Yeah, so here you see kind of what it looks like before you put the paint scheme on. And here we're still integrating some of the systems. Also, this is a great chance to highlight some of the other weight-saving features of the spaceship. So they're not pictured here, but this is the leading edge of the wing. And typically what goes here is actually bottles of air. So many of the spaceship systems are actually driven by compressed air, which is generally lighter and less complex than using something like hydraulic fluid or electromechanical actuation. So by using compressed air, this is actually how we pressurize the cabin. It's the air that everyone breathes inside. It's also how we deploy the feather, how we move the feather both up and down, deploys the landing gear. So it's another one of those weight-saving features that, air is pretty light and it makes the ship fairly robust. We carry plenty of air. We've got lots of extra, so there's no risk of running out. It controls the speed brake. It controls the reaction control system. So it's how we navigate when we're in space, since there's no air to push off against. So yeah, a lot of interesting design features on this spaceship that allow us to do our mission. So let's talk a little bit about the operations. So here is a picture of Spaceport America. This building we call Gateway to Space. This is where our customers will go and look at the space flight, look at their space flight out of New Mexico. So here's a cool picture. I love this one. You get to see both the mothership White Knight 2 and the spaceship hanging in between there. And so it kind of looks weird. At first glance, you might think there's 3 airplanes here, but it's actually only 2. And we have a twin fuselage design on the White Knight, as you can clearly see here. Another cool thing to point out here is you notice some similarities in between what the spaceship and what the White Knight 2 look like. So this is another way where we try and reduce complexity and reduce costs we actually use the same tools to build both the White Knight 2 and the spaceship. So these cabins are fairly interchangeable. Obviously, there's a lot of different systems inside of the spaceship, so the cockpit does look a little bit different here and there, but for the most part, these cabins are very, very similar. And so this allows us to increase the reusability by reducing the cost of having to design and tool multiple different things.
We did have a question come in about that. So then in the case of the, I think it's the White Knight 2, so not the spaceship itself, but the planes who are bringing it up. Is there only one pilot on that aircraft, or is there 2 different pilots in the 2 different bodies?
Great question, yeah. So both the spaceship and White Knight 2 each have 2 pilots. And we say 2 pilots and not a pilot and a co-pilot because both pilots are actually doing an equal amount of work. There's a lot of systems to manage and a lot of mission management. And so we have 2 people in each cockpit kind of managing the entire mission. Now you might wonder, if White Knight 2 has 2 different fuselages here, 2 cabins, which side do they fly on? Is it one, is it both? Well, the answer is the right-hand side. If you see in this picture, there's a little hole. That's the cabin door. This is kind of best kept secret. It's not that much of a secret, but these windows on the left-hand side, excuse me, those are actually just stickers. They're not windows. They just look like they're windows. So we just wanted to get some symmetry there. But most of the vehicle systems on White Knight 2 are on the right-hand side, as are the pilots. And so we have a pilot that's able to see out the window and keep an eye on the spaceship during flight and release. And then the other pilot, doing all of the other piloty things that they do.
And so just for clarification, that left spaceship, the left aircraft is all sticker windows. There's nobody inside of that.
There is nobody inside. It is mostly empty. There's a few vehicle systems in there, but there aren't any people in there. Nope.
Awesome. Thank you.
Great question. All right. I think it's time for another video.
Spaceport America is the first dedicated commercial spaceport. And it's just incredibly exciting that we have now made it to this point where we're unveiling operational readiness of Spaceport America. The distinction of operationally ready means that we are graduating the facility into commercial service. We want to have this be a remarkable historic facility that when people arrive at, they feel, yes, this is the place that I'm going to be going to space from.
Now that we've brought the White Knight 2 down to its final home in New Mexico, we are in the process of doing a lot of airfield and airspace checkouts and use of our brand new mission control, completing the fit out of the operational areas of the building, moving half of the team, and getting White Knight 2 finally down in New Mexico for good is a huge milestone and a huge step forward in us being ready to have Spaceship down there and complete our flight test program in New Mexico.
For me, it's an amazing honor to welcome the pilots here today. We've got a beautiful space for them to come and experience. The way that we're talking about the story here in New Mexico is based around a social environment. We've got an amazing barista island here, which is hosted by our fantastic team of hosts. Also, just materially, we're talking back to nature and the landscape beyond us here. It's going to be an area that in the future we can continue these wonderful celebrations and also deliver an amazing space for our future astronauts, their friends and family, and of course our broad team of people here at Virgin Galactic who are really going to bring this experience to life. And the story continues upstairs when we move up to mission control. We go much lighter with materials and it's almost replicating rising through the clouds and flying. Mission control is the beating heart of the real hub and the center of what the organization's about. In the future, the continuation of our story takes us upwards and into the astronaut lounge. It's the final chapter in completing our spaceport, and I'm really excited that we're on the dawn of commercial operations here, and I really look forward to offer a truly memorable Virgin experience.
All right, so that was a little tour of what it's like out at the spaceport and Gateway to Space. So let's talk a little bit about what it's like there. So as you kind of mentioned, the Gateway to Space is designed out there in the New Mexico desert. And it's kind of built to like blend in with the landscape. And so a lot of the design features, this is where that customer experience that Virgin Galactic is so good at comes into play. And so here we're showing a picture of the Gaia Lounge. It's on the ground floor. And we talked about a little bit the design in the video, but here we're focusing on like those earth colors. It's to remind our customers or to make them feel like, hey, this is where it all starts. This is where your journey begins here on Earth. And this is actually kind of the hub of like the gateway to space, if you will. Our future astronauts and customers will hang out here with their and eat their meals, meet their training, or meet their teams who they're hanging out with, meet the crew, have all their meals and beverages here. It's a lot like the kitchen in your home. They say the kitchen is like the hub or the heart of your home. Well, this is kind of like the heart of the spaceport. This is the gathering spot. We go to our next level. We kind of, as we rise through the spaceport or through Gateway to Space, the colors change a little bit. And so now we're seeing this white airiness as we kind of ascend through the clouds. And a lot of attention to detail in the design of this building is the pilots' offices and lounges up here. And so, obviously the pilots fly through the clouds. Our mission control center is up here. So on the right-hand side of that other screen there, you see our mission control. And so even though we've got, 2 pilots in the spaceship and 2 pilots on the White Knight 2, behind the scenes, we have, dozens of people backing them up in our mission control center, especially as we're now here in flight test trying to prove out the design and get it ready for commercial service. So you have people monitoring. We collect lots of data. We're monitoring, hundreds, if not thousands of signals. Trying to make sure that the vehicles are safe and that we're proving out what we need to prove as we get ready to take to the next step in putting people in the back and getting commercial service up and running. And then above this is the astronaut lounge that has not been publicly released. So I haven't seen it either, so don't hold it against me. But there is more, and look out for that as we continue to look forward to releasing that. So here's a little infographic that kind of shows a brief overview of the entire mission, and it kind of gives you, lets you know what the experience may be like if one day you become one of our customers, our astronauts. So you'll arrive at the spaceport, you and your family, you'll meet your fellow comrades who will be training with you on your flight. You arrive about 4 days before the flight to do your training, which we'll talk about in a second. When your day comes, flight day, you'll get into the spaceship, you'll climb up. It takes about 45 minutes to climb up until takeoff and before you get to cruise altitude or for release, about 45 minutes to an hour. Our pilots will release the spaceship. A couple seconds later, they will hit a big red button. There's a big red button in the center of the cockpit that you pull on to light the rocket motor. So the pilots pull that big red button, and about 6 seconds later, you're flying faster than the speed of sound. So there'll be a sonic boom for anyone watching on the ground, which is pretty fun to watch and hear. After we break through the sound barrier going faster than Mach 1, the pilots point the nose up. You'll feel about 4 Gs as you do that pull. We call that the gamma turn. You turn from horizontal straight to vertical flight. And that's where we spend most of the flight just going straight up. And so the rocket motor burns for about 60 seconds. In that time, you go from about 50,000 feet, about 40 to 50,000 feet, to 150,000 feet in 60 seconds. And so as soon as the rocket motor turns off, that's kind of when your 0G experience begins. So you'll be, as a customer or a passenger, you'll be instructed you're free to move about the cabin, if you will, unbuckle, and then you start to float around and then enjoy the view, do whatever you want to do in space, backflips, twirls, float around, all that good stuff. During that time, the vehicle will continue to float up to the highest point in the trajectory. We call that apogee, while also folding the vehicle in half in the feathered or feather up position, getting ready for re-entry. And so this whole dash line is kind of your 0G experience in feather up. And then at some point, the pilots will tell you, all right, you probably get back in your seats, time to go home. You buckle up, and then it's an exciting ride on the way down. Like I said, it's kind of like doing a belly flop back into the atmosphere. It's a very slow belly flop, but it's several minutes in the feather up position re-entering the atmosphere. And here the feather system is helping you slow down and decelerate back to a safe altitude and speed where you can go what we call defeather. And then once the feather is down and locked, you fly back like a normal airplane on the same exact runway. Land on the same runway you took off at. And then, that's equally exciting, I think. And then you go back to the spaceport, Gateway to Space, and you party like you probably never partied before. I'd say Virgin has been known for throwing some pretty cool parties. And I think this is, after you've gone to space and come back, I'm sure this will be one of the most exciting times of your life and of our customers' lives, and with the requisite celebrations. So it's a quick overview of the stages of flight and kind of what to expect if you come fly and when our customers come fly with us. All right, I've got one more video. We recently did a cabin reveal, so let's see what it looks like on the inside of the spaceship.
To fully embrace the design opportunity within the cabin, our spaceship crew seat really is an iconic feature, and we've tailored our seats for each individual astronaut. We've used the highest grade aluminium and carbon fiber manufacturing techniques, and we've cantilevered the structure from the cabin sidewalls. Your seat's also dynamic and enhances comfort during each stage of your flight. When you leave your seat in space, it reclines to maximize cabin space for you to enjoy weightlessness, and it remains reclined during re-entry, so we direct and optimize G-forces without detracting from the thrill of the ride. We've provided each astronaut with their own personal digital display within the seat backs. The display gives us the opportunity to share live flight data with you, so speed, G, boost time that's remaining of your flight, all helping provide more memorable magic touches to your experience. Under Armour manufactured the technical knit material. It's extremely lightweight and requires no stitching to just ensure that perfect fit onto your seat. We also worked closely with Seymour Powell to develop our colour and material palette. We wanted a harmonious connection to your spacesuit, so we've used blue and teal colours and hues to work with that. But also, we've incorporated gentle nods of colour to space itself and a connection back to Earth. The cabin's lined with an extremely lightweight and soft engineered foam with a honeycomb structure. Functionally, we were able to improve thermal and acoustic qualities of the cabin, but the lining also provides a soft touch as you explore the cabin during weightlessness. Your view's the focus of your time in zero-G, and to guide you towards experiencing this incredible moment, we've got 17 windows, each bordered by a soft circular halo which helps focus and frame your view. We've designed the halo edges to allow you to move around the cabin and to perfectly position yourself to view Earth below. In zero-G, the cabin effectively becomes a 360-degree climbing frame. We're fortunate enough to work alongside several astronauts at Virgin Galactic, and their experiences of space tell us that it's deep, deep black, and that Earth is extremely bright, giving us the most beautiful and natural light source on board. But we also know the importance of lighting in our environments and how we can use that to enhance your experience. So we've taken the opportunity to incorporate lighting into our spaceship as well. We use it functionally, for example, when you're boarding and preparing for your flight. We've also programmed it for different phases of your flight, whether it's using a calming color on your cruise up to release altitude, or we can add more vibrancy through the energetic rocket boost phase, or we turn it off completely once you're in space. And it's during this phase we let Earth itself provide the ultimate beautiful lighting. We know our customers want to perfectly record every aspect of their experience, and we've ensured that we've got this covered. There's no need to take your own camera, as we all know your time is going to be spent enjoying weightlessness and those amazing views back to Earth. We've built in 16 cameras on board to record every one of those moves that you make on your trip. We're always wanting to add those personal, magic moments to all of our experiences, and we've added another one on board with the inclusion of a large circular mirror at the back of the cabin. While 16 onboard cameras will be capturing your every move for later viewing, we felt you should also be able to see yourself enjoying the freedom of weightlessness in real time, illuminated by the natural, beautiful brightness of the Earth.
Wow. Every time I watch that, I get excited. It's going to be a phenomenal experience. The views are incredible. So let's get a little bit into the training aspect. And, you know, we saw the narrator talk a little bit about the design of the seats and how they fold out of the way so you can enjoy more space in the cabin. So the seats have a fairly clever design in that, you know, they're upright for your boost profile, and then they fold they fold back down in kind of the laying position for the re-entry back into the atmosphere. And so, it serves as having more space in the cabin during your space flight and during your weightlessness period. But it also serves a functional purpose, as the human body is really good at taking high acceleration, or G's, in this direction. So kind of like the back and forth direction through the body. And so when you come back down to the atmosphere, you're going straight down. And so by laying down, those G's are acting in a way that is not too harsh on the body. So, you will experience some extreme G's, probably like riding a roller coaster, but like a much better roller coaster, and for much longer and much more exciting, and the views are going to be unparalleled. So someone was asking about the tolls on the body and what the experience is like and with the training. So this is the answer to that question. We've designed the spaceship to try and minimize the negative aspects of the high G, but you will be trained when you come to the spaceport to what to expect, and then how to get the most out of your experience. We also have medical personnel on staff that will do your checkups and make sure that you're in good health, and that you're able to enjoy the experience as much as possible and work with you. Let's also talk a little bit about training. So although not required, many of our customers do like to do their own pre-flight training just to get excited. You can get into a centrifuge, which just basically spins you around really fast. That's one of the ways you can get to experience a similar level of G without actually having to leave the planet or get into an airplane or anything. And then some people actually go do parabolic flights or zero G flights. Companies called like zero G, where you go up on an airplane and you fly these parabolic trajectories, and on the way down, you kind of feel weightless for 30 seconds or so. I think that's it for this slide. So I haven't done too much training myself, but recently I did get the opportunity to fly with one of our pilots in. We own an acrobatic airplane here at Virgin Galactic. It's also helped keep our pilots current in high G training and flying high performance vehicles, since the spaceship is a very special one-off vehicle currently, and it takes an army to get that vehicle in the air. And so this is kind of a more readily way to keep the pilots trained and current and do their high G training. So I'll explain a little bit what's happening in this video, but this is one of our pilots, Forger. He's taking us flying straight up and then flying us upside down. And then he's getting us into what's called an inverted flat spin. And it's about as disorienting as it looks for me. I am not flying the vehicle, he is flying it. But these are the types of acrobatics that our pilots are capable of. And suffice it to say that you're in very good hands with a Virgin Galactic pilot. They are highly trained, highly skilled, and some of the best pilots in the world. It's a fun ride. So in this flight, in the extra, it's called a Extra 300, you also get the chance to simulate the spaceship G profile. You can't simulate all of it because this airplane doesn't go to space. It's not a spaceship, it's just a regular airplane. But you do get some of that gamma turn I was talking about as you point the nose from horizontal to vertical. You don't actually point it up to do that. You do that in a left or right turn because, again, this isn't a spaceship. So you do your best to simulate what really happens. But you get the feel of what that feels like in the body. And it's a lot of fun. It was great. I would recommend. All right, so like I said, our overall mission is to try and inspire future generations, and part of that is we're trying to provide a post-flight training opportunity for our future customers and our astronauts. And so, as mentioned in that cabin video, there are cameras all over the cabin. In this age of social media, pictures didn't happen, right? So we'll be sharing lots of videos and pictures of the entire flight with you, and then there's like the next big thing is like, what's your mission? What do you do next? So a lot of people expect to have a life-changing experience when they fly with us. And so we're hoping to be able to channel that and into some productive venue and kind of create a community of our future astronauts and share that experience with each other and with the world of what that is like and how that changed their outlook of life or maybe the world. So that's a lot of it. I wanted to share with you a little bit what I do, and maybe what you give you some insights as to what it's like to work here and as an engineer. So I mentioned briefly, I lead the loads and dynamics team, and that's a lot of things. And so I won't get into too much gory technical detail, but basically, in a nutshell, it is my job to figure out how strong things need to be. So that is kind of the discipline of loads or external loads and dynamics. So my elevator pitch is, we develop the forces, moments, pressures, and accelerations and vibrations that determine how strong the aspects of the vehicles and their subcomponents need to be. And so we use a lot of interesting tools for that. We use simulations, we use test data, we use math, physics, equations, models. It's a very, very fun and exciting work to do. Yeah, so if you have any questions about that, happy to go into it. This isn't a technical discussion, so I will spare you all the gory, interesting, and fascinating technical details. But it does slide in well into kind of our next slide. So maybe one day you want to work for Virgin Galactic or a company like us. And so, what are the opportunities that you may have to come, and what can you do? So first, foremost, ITAR. That's basically just a fancy acronym that the government says that we're a U.S. company, you kind of have to be a U.S. person in order to work here, given the nature of the work that we do and some of the technologies that we deal with. We also offer summer internships. I think applications are open now or closing soon. Don't quote me on that, but if you're interested, look into that ASAP. We hire people in all sorts of roles. Yes, we're heavily an engineering organization, but it does take a whole lot more people to run a business in engineering and science and things like that. So personally, I come from the flight sciences organization as a loads and dynamics engineer. We also hire in the avionics, electrical, flight operations, testing, propulsion, structures, pretty much anything you can think of: chemical engineers, aerospace engineers like myself, electrical engineers, mechanical. I even have a mathematician on my team, actually, classically trained in math, but he actually took a liking to engineering. So you don't have to study engineering to get into engineering. And then we also, like I mentioned, those non-technical disciplines like finance, supply chain, legal, safety, security, IT, hospitality, communications, obviously pilots. So there's tons of ways to get involved in Virgin Galactic, the Spaceship Company, and just STEM and the commercial spaceflight industry. We offer jobs at all levels, entry level and heavily experienced, and we offer opportunities to new graduates every year. So happy to dive into any other details that you're interested in, but that is the end of my presentation. So if anyone has any questions, I'll take those.
Awesome. Thank you so much, Tui. That was absolutely fantastic. Just personally, I was just very interested in everything you were speaking about as well. So it was killer. We got a lot of interaction on YouTube. Some of the questions that came in, the students are wondering, so why New Mexico?
That's a great question. So I'll give you my best answer. It's probably not the full or whole answer. So part of it is the customer experience, right? So we try and pick points on Earth, in this case in the US, that are going to offer spectacular views. And so it's hard to really imagine what the view may look like from here. So go into Google Earth if you want and check out what the view may look like from different points on the Earth. But I know all of our space flights so far have been from Southern California, and we're close enough to the coast where you actually get a tremendous view of the entire Pacific Ocean. You can see as far down as the Baja Peninsula, up the mountain range, up to Northern California, and even into Nevada. So you get pretty spectacular views, and you get similar views in New Mexico. So that's kind of like the customer experience part of it. I'm sure there were many business reasons as to why New Mexico came, but I think the location and the airspace is also, it's a unique set of airspace in New Mexico that kind of favors our type of mission.
Great. And have you been to New Mexico?
Not yet. Fingers crossed one day, but it's on my to-do list. I'm hoping to get out there one day soon, hopefully next year. But many of my colleagues work there. About half of my team that works with me travels there on a fairly regular basis. So we're going back and forth between California and New Mexico fairly often as we're kind of in flight test and operations, some hybrid.
I think you kind of touched on this earlier, but one student did have a question about how long it takes to build a spaceship.
That's a good question. So you've probably heard of like the learning curve, right? So anytime you do something for the first time, it takes a little bit longer. And then every time you do it after that, you practice and you get a little bit better and you get a little bit better. So I'd say the first spaceship took about, 2 years to build, or the one that we're flying now. But we're building more as we go. And so we're hoping to reduce that time until a point where we can have an entire fleet. So I'd say on the order of a couple of years, but that can come down considerably with the right attention.
Okay. And again, you touched on this earlier, but just to restate here, how you test the spaceships.
Yeah, we actually have some great videos on the Virgin Galactic website, Learning with Virgin Galactic, but I'll touch on it. We test everything. So there's what most people kind of see and think about testing is our flight testing. That's usually the last thing we do before we get into flight testing, which is very risky and a lot of implications. We have 2 pilots, so there's people on board every spaceship we fly. We do a lot of ground testing, both on the fully integrated structure, the vehicles, and at the subcomponent level. So everything from what we call coupons, which will just be like, imagine small pieces of carbon fiber that you just bend and bend and bend until they break. In engineering, we like to know when things break. And so knowing when things are going to break is actually something we need to know in order to keep things safe. And so we test things to failure often. And then we test components. We test with vibration testing, environmental testing at hot temperatures, at cold temperatures. We do materials testing. We do structures testing. We do human factors. We have a simulator as well, a flight simulator that our pilots train in that also helps us test out some of the avionics or, to water it down a little bit, just kind of like the dashboard of the spaceship so we can test out the electronics. We have several test labs where we check out electronics and wiring and electromagnetic interference. So we do all types of testing on the ground ever before we step into a flight test scenario to make sure that our flight test is in the best situation possible.
Great. And one student would like to know, how long do you think it is before Virgin Galactic begins taking customers, and how much would that cost?
Yeah, so I think it's fairly soon. We've publicly stated that we're trying to take our founder, Richard Branson, to space early next year, sometime in the first couple months of the year. So it's kind of after we take Richard Branson to space is when all the dominoes start to fall in place in terms of getting us to commercial service, where we're sending, regular, semi-regular paying customers like you and I. Right now, tickets are about $250,000. I know that sounds expensive. That is a lot of money, but it is the cheapest ticket you can buy to space right now. So right now it's about $250,000. Price subject to change based on the environment and whatever needs to happen from the business case and all that. But historically, it's been about that, and that's what most of our future astronauts, which we call our customers, have put their deposit based on. So I'd add the point, a lot of people think that you have to be like super rich or heavily wealthy or just super lucky in order to like get to fly. And while that does certainly help your case, we have all types of customers who signed up with us. People who were selected in the astronaut team like back in the 70s and 80s, but then the program got canceled for whatever reason. And we've got teachers and nurses and people who are just very passionate about space and space flight. And so it does help to be wealthy, but you don't have to be. If it's your passion, it's just as like buying a house if you really wanted to. So it is within reach.
Great. And so you mentioned a little bit about the sonic boom after takeoff. And so one student would like to know what it feels like being on the spaceship when the sonic boom happens.
Well, I can't speak from experience, but I don't think you feel anything. I think from your perspective on the spaceship, you just feel like you're on a rocket taking a ride. You don't really feel that boom because it's happening. The nature of a sonic boom is it's a pressure wave surrounding the spaceship that kind of kind of like a little explosion around the spaceship, but only in sound, and it propagates away from the spaceship. So by the very nature of a sonic boom, you probably won't hear too much in the cabin. It just kind of dissipates into the atmosphere and whoever's nearby.
Great. Okay. This is just so fascinating. Again, personally, I'm just the whole time, totally honed in. So yeah, super awesome. It looks like that's all the questions.
Cool. The sound. Sorry to interrupt, but hearing a sonic boom is very cool. And if you've never heard one before, it can be very alarming if you don't expect it. It sounds like a small explosion far away, depending on how close it happens. If you've ever been to an air show, they don't break the sound barrier at air shows, although they could, because it would be deafeningly loud at the altitudes that airplanes fly. At air shows, windows shattering, babies crying, cats meowing, things like that. But in the very near future, you'll be hearing some sonic booms over New Mexico.
That's so awesome. This is so exciting. Okay, great. Yeah, I'm not seeing any other questions popping in the chat right now. Just a lot of thanks from the students in the chat for having Virgin Galactic on. Just so you know, the design of the Spaceport America and also the ship is a huge hit for a lot of the students. So they got a lot of hits on there. So awesome. Well, Chewy, thanks so much for coming on. Thanks for showing us all the ins and outs of what you're all doing down there at Virgin Galactic. And it's just such a pleasure again to have you on.
Thanks, Will. It was so much fun, and I hope everyone got something out of it. And look to the skies. We'll be there soon.
Awesome. Will do. We will definitely do that. And of course, it's a really cool New Mexico connection for a lot of our students. So thanks to everybody who's tuned in today for our presentation. Again, sorry for the technical issues early on, but we're so happy that the stream stayed going strong for the whole demonstration today. So again, thanks so much to Virgin Galactic for coming on. And just a reminder, today at 1 p.m. we have Fidelity on, talking about what is credit. Should be a really interesting and informative presentation, so be sure to check that out. Otherwise, again, we're going to be updating our website with some of these other sponsors I was talking about early on. We have Honeywell coming on this coming Friday, so stay tuned for that. And just again, shout out to all of our fantastic sponsors who, if it wasn't for them, this festival would not be happening. Honeywell, Fidelity Investments, Aztec Machine Repair, Air Force Research Laboratories, and then the other wonderful sponsors you see there in the bottom left of your screen. I think that's it. It looks like, yeah, but just I always have to glance back at the chat. But again, thanks so much for tuning in today. We will see you at 1 p.m. today. Stay healthy and stay safe.